So in this video, I'll be covering about the fractional knapsack using the greedy approach. There are two problems related to the knapsack, that is fractional knapsack, which can be solved using the greedy approach. And the next one, that is knapsack, 0 or 1 knapsack, which can be solved using the dynamic programming. So coming to the knapsack problem, that is given certain kind of the knapsack, that is a particular bag, and given certain kind of the items, that is n number of the items are being provided, and certain weights as well as profits are being associated. That is for each item, like take for example item 2, and there are n number of items, and for each item the profits are being associated and as well as the weights are being given. And the knapsack has certain kind of the capacity, that is m equal to whatever the value that you mention in the input. And what is the problem of the knapsack is you have to maximize PIXI. That is, you have to maximize the profit by considering those items with the maximum profit into the knapsack. And there is a certain kind of the condition. That is, whenever you add certain kind of the item into the knapsack, then it should not exceed the knapsack capacity or the remaining capacity. And xi should can range between 0 to 1, that is 0, 0.1, 0.4 and so on till the 1. It can be also equal to 1. The fractions can also be considered in this kind of fractional knapsack problem. So pi indicates the profit, xi indicates the item that you have considered, n indicates the number of items, wi indicates the weight of that item, m indicates the capacity. And we shall take a particular example related to fractional knapsack, which can be solved using the greedy approach. If you consider the algorithm, that is, according to the algorithm, there are certain prerequisites which are being assigned, and certain kind of the statements are being included, which can be solved using the greedy approach. That is, the prerequisite is it should be ordered such that pi by wi is greater than or equal to pi plus 1 by wi plus 1. That will explain with an example. And for I equal to 1 to n, do x of I equal to 0. This is the initial step that has been used to start with, where initially we are considering no items are being added into the knapsack. That is, when I say x of I equal to 0, that is, items are not being added. That is, x of 1 equal to 0, item 1 is not being added, x of 2 equal to 0, item 2 is not being added into the solution set. And when I say x of 1 equal to 1, then item 1 is being added into the solution set. And u equal to m, you're storing the knapsack capacity into some kind of the temporary variable, that is u. And the items to be taken, that is, for I equal to 1 to n, do if w of I is greater than u. That is, the weight that, the item that you are adding, and what is its respective weight, and what is the value of u. Either it can be the knapsack capacity initially or the remaining capacity after adding certain number of the items. So if it exceeds, that is, by adding certain kind of the item into the knapsack, if it exceeds the knapsack capacity, then break, come out of the loop and find what is the portion of your item to be included to solve this kind of the problem. And if this condition is the false condition, that is, if w of I is greater than u is the false condition, what can it interpret? That is, the item that you are adding into the knapsack does not exceed the knapsack capacity, and that is how you can add that item. You can also observe x of I equal to 1. We are considering the entire item, and after adding the entire item, the remaining capacity of the knapsack should be calculated, which is being given by the statement u equal to u minus wi. And I will take certain kind of the example which can be solved using the greedy approach for the knapsack problem. So consider there are a number of items, that is, there are totally 5 items which are being present, like your item 1, and similarly item 2, item 3, and similarly item 4, and as well as item 5. And the next is, that is, as I mentioned, each kind of the items the profits and weights are being associated. Consider the profits of item 1 to be equal to, that is 50, 120, and the next one that is 150, and the next one that is 210, and as well as 240. And consider the weights to be equal to 10, 20, 30, 40, and then 50. So the prerequisite for this kind of the knapsack problem, which can be solved using the greedy approach, is it should be ordered like pi by wi greater than or equal to pi plus 1 divided by wi plus 1. So 50 divided by 10, that is 5. 120 divided by 20, that will be equal to 6. 5, and somebody is 5.25, and the next one that is 4.8. So the items are to be ordered in such a way that pi by wi is greater than or equal to pi plus 1 divided by wi plus 1. Find out what is the maximum. So 6 is the maximum pi by wi value. So this will be your first item. And there are two next maximum values, that is 5 and 5. You can take either of this one. That is, this is considered, this is your second item. I'm sorry. We have 5.25. This will be your second item. And the next item, it can be either item 3 or item 1. And the next item, consider it is equal to 4. And the next item, according to the pi by wi or the 4.8, will be the last value. So here, take the first item. The first item, that is according to our scenario, that is item 2. And what is the weight? Weight is equal to 20. Of course, I should also provide the knapsack capacity. Assume the knapsack capacity to be equal to 50. So by adding the second item, does it exceeds the knapsack capacity? It does not exceed, because the item that you are adding has the weight to be equal to 20 and the capacity is 50. So calculate, you can add the item 2, and how about the value of the remaining capacity? That is 50 minus the capacity of the item 2. That will be equal to 30. So you are adding the entire second item. So you are adding the entire second item. And what is the next maximum pi by wi? That is with the pi by wi value to be equal to 5.25. This will be your second item. And by adding the item 4, does it exceeds the remaining capacity? So what is the capacity, what is the weight of item 4? Item 4 is equal to 40. And how about the remaining capacity? That is 30. We cannot place item 4 into the knapsack because it exceeds the knapsack capacity. And what should be done in such case? If you recall about the algorithm in your previous slide, that is, if the weight exceeds, then break, and then what is the remaining capacity? Remaining capacity equal to 30. And what is the capacity of, what is the weight of the item that you are including? That is 40. So what are the items to be added? The items to be added are, that is item 2 plus 30 by 40 of item 4. What are the weights? Item 2 weight is equal to 20 plus 30 by 40 into item 4. What is item 4? Weight, that will be equal to, that is 40. So that is equal to 20 plus 30, that is equal to 50. This is the capacity. So we can have these items to be included. And how about the calculating the profit? That is item 2's profit. Item 2's profit is that is 120, and 30 by 40 of item 4. That indicates 30 by 40 into item 4's profit, that is equal to 210. So you need to sum up these values. That is 120 plus 30 by 40 into 210. Whatever the value that you get, I believe like the value is 277.5. This is the maximum profit that can be earned and which can be solved using the greedy approach for the knapsack problem.